Welcome to PV Online Physics, and today we're going to take a look at projectiles that are launched horizontally. And that's going to be important to us because what that means is we only have to worry about the initial velocity in the x direction. Since in this case, all of my initial velocity is all going in the x direction, so initially that's all we have to work with. Okay. So we have our two equations, one for the range. For the range, remember, is the horizontal distance. So for example, if I went from, let's say, from here to here, this is going to be my range, that distance. From the edge of the cliff to the point where it lands, that's going to be my range. We compare that with the vertical displacement, and the vertical displacement, whoops. Didn't mean to do that. Hold on. The vertical displacement is going to be this way. So we've got our displacement in the y direction. That's going to be the up and down distance. The range is going to be the horizontal. And so if you take a look at this, you can see that as the cannonball falls through the air, it's moving horizontally at a constant speed because gravity only acts straight down. Now in this example, we're going to make gravity, just for this example, let's make it negative 10 meters per second squared. It'll just make our math a little bit easier. So let's take a look at what happens at 1 second. Where is this going to be after 1 second? So we were given that the initial velocity of the projectile was 100 meters per second. So when I calculate my range, my initial velocity was 100 meters per second. After 1 second, that means that it's going to travel 100 meters horizontally. So down here, this would be this horizontal. This range right here is going to be 100 meters. Now let's take a look at the same thing over here, only now we'll look at the displacement in the y direction. So we're going to use 1/2, and again we're going to use negative 10 times 1 squared, and that's going to be negative 5 meters. So after 1 second, it will fall in a vertical displacement. This guy is going to be 5 meters. It's negative because it's falling down. Now let's take a look at what happens at 2 seconds. So my range is going to be 100 times 2. It means now I'm going to be 200 meters away. So from this point to over here, that's 200 meters. After 3 seconds, it would be at 300. And so on. We're moving at a constant velocity horizontally because gravity only acts down vertically. So let's calculate our dy once again. And our dy is simply the displacement in the y direction. So I take 1/2 times negative 10 times 2 squared. And now let's take a look at this. So because the time is squared, that now becomes 4. 4 times 10 is 40 divided by 2. Look at what happens to my vertical displacement. It jumps all the way to negative 20 meters. That means I'm going to fall farther in the next second because we're speeding up vertically due to gravity acting on it. Let's do one more example, and let's say after 12 seconds. So after 12 seconds, my range would be 100 times 12. That means we will have gone horizontally 1,200 meters. And vertically, let's see what this is going to be. So I take dy equals 1/2 times negative 10. Oops. Negative 10 times 12 squared. This means that my cliff then was at a height of negative 720 meters. And I get that, excuse me, pardon me, by taking the 12 squared, which is 144, times 10 divided by 2, negative 720 meters. So the main idea to get here is that our acceleration is only down, and that horizontally we're moving at a constant speed. Gravity is acting only down, and break up your problems into these two, into the range equation and your displacement in the y direction. You should be able to take a look at some problems now.